the price-demand feedback loop. This is an important feature in the energy and climate system. It's at work, kind of behind the scenes in En-ROADS. I want you to understand it. What happens is that climate solutions that lower the price of energy have the effect of increasing demand for energy, therefore weakening their ability to reduce emissions and reduce temperature. And on the other hand, climate solutions that actually increase the cost of energy will decrease demand and strengthen kind of a multiplier effect on its overall ability to reduce future temperature. So price down, demand up, price up, demand down. All right, let's go see where it shows up in the simulator. So the first place we're going to explore is imagine, and these are things that climate solutions that will increase the price of energy. The main one to direct you to is carbon price. So here's a carbon price. You can see what its impact is here on the, at least in the front default graphs in the model, but looking underneath a bit more, what is going on besides this really big change to the fuel mix? Let's look underneath at the cost of energy. So I'm going to pull up over here for the cost of energy, and we can see that energy costs go up a good bit. If energy is more expensive, there's more of an incentive to invest in energy efficiency or to conserve energy, and therefore energy demand goes down. See the blue line departing from the black line. It goes down not a lot, but somewhat. This is something that will be a multiplier effect on its ability to reduce greenhouse gas emissions and reducing temperature. It makes the solution even stronger. This isn't just about a carbon price. This also shows up when you just tax coal, oil, and gas, for example. Now let's look at it the opposite way. Imagine new zero carbon energy. So it's going to come in really inexpensive. It's going to spread around the world because it's so inexpensive. Let's go see where it shows up. So here's the cost of electricity. Over time, you can see the green line of wind and solar getting cheaper and cheaper and cheaper. If we imagine new zero carbon energy, here it comes. Watch the orange area lower, even lower than wind and solar, really inexpensive. Therefore, it's going to spread around the world. Here you can see it growing. See the orange area growing as it spreads. But behind the scenes, what else is going on, particularly that leads it to not have such a huge impact? There's a big answer around the delays in the system, but I want to explore the price-demand feedback loop. Let's go look and see, well, if you have cheap energy around the world through this new supply, overall cost of energy goes down. See the blue line departing from the black line. If energy is less expensive, there's less of an incentive to invest in energy efficient technologies and systems, or less of an incentive just to turn off the lights and practice energy conservation. Therefore, what happens to overall energy demand? Energy demand goes up a little bit, not a lot, but up a little bit relative to what it would have been otherwise. That leads to a little bit less of a reduction in emissions than we would have gotten otherwise, and less of an impact on temperature. Oh, actually, and it shows up not just here, but also with inexpensive uranium-based nuclear, also with cheaper and cheaper wind and solar, the same impact. All right, so the price-demand feedback loop, the idea that price comes down, demand goes up, price goes up, demand goes down, weakening some effects with a compensating feedback and strengthening others. Hope this is helpful. Go get them.